So this project we've titled Building Historical Records of Flooding for Alaska Communities. This was a project funded partially by the National States Geographic Information Council, DGGS, and then NOAA. It was NOAA Digital Coast project. So the main goal of this project was really just to improve the understanding of flood impacts for Alaska coastal communities. A fairly broad sentence right there, improve understanding, but intentionally that way just to get an idea of what can actually be done, what the current status is of current knowledge of flooding, in ways that we can make it better. So what we're thinking is something simple, something like this graphic on the right here, where this is a flood staff that just shows elevations above a local tidal datum. It has information about times when previous storms reached those certain heights, and then also these colored categories of flood impact levels, some heights of local infrastructure, and there you go, a very simple, straightforward graphic that improves the understanding of flood impacts for a specific community. So one of the objectives for this project was to have a method to actually estimate the height of historical storm surge floods. So just actually looking at those past flooding events, seeing how high they got, and then also defining flood impact categories for these communities. When does the flood actually impact the community? And ultimately displaying the results in a simple, easy way, such as this graphic that takes up 10% of the screen here. So first I'm going to talk about storm histories, a nice little painting of a devastating storm. So storms are, of course, a problem that people have on the coast, and it comes from the environment. They can natural phenomena, storms come in, they cause flooding, they cause erosion, and they cause damage to infrastructure that's built on the coastline. We have a photo database, which I'll talk about later. And if you just search the word flood in there, you can see all these little purple circles popping up of all these different photos of flood events over the years, affecting pretty much every community on the coast. And these can be, of course, major events that can flood homes and damage roads, but even minor events of flooding, such as just hitting beaches where people have parked their four-wheelers or their boats, can cause major issues for these subsistence-based communities on the West Coast. So another issue we have is data. And I kind of pose this question, and it's semi-rhetorical, but we'll see kind of what I really mean here later. But do we know the risk of flooding? And risk is traditionally, it's measured by the probability of an event and the severity that it has. And I would ask, for a given community, can you actually answer the following questions? How often does flooding occur in that community? How high have the floods reached in that community? And most places don't have water level sensors. And so for most places, you can't exactly answer these questions. There are certain techniques like modeling that can give you ideas of this. And so I have an example here from the Army Corps' Wave Information Studies website, where they have these modeled probabilities of storms and storm return intervals. And that's a good idea of how often flooding might occur and how high it might get. But the other question is, how severe are these events for the communities specifically? So a flood might get so high that the community might be higher up. So you need to know what kind of impacts they actually have. And this was actually an offshore model near the community of Golovin. And the storm that they modeled as a 30-year storm is the one in the picture on the bottom here that flooded the entire lower part of the community. So that kind of information combined, looking at the probability of an event and the severity that it had, gives you an idea of the risk that they face. So what we wanted to do is actually put together this history of flooding. And one of the main issues is right now, flood resources are just all over the place. There's no one source you can go to find everything there is to know about flooding for a specific community. So we started actually putting it all together. This is just a simple table of a few sources that I looked through, and combine to start to put together a flood history for the community of Golovin. We did this so far for Golovin and Hooper Bay, and I'll show you at the end other places we'll be working on. And then this presentation is mostly going to focus on Golovin because they have a rich storm history. So for these sources, what we do is we look for flood data. And that can range from a lot of things. Some of the best information, other than a water level sensor itself, is just photos of flooding. So here's a photo from November 2011. Also, another storm that flooded the lower part of the community. That's a great data resource where we can look at this, see how high the water was, see the impacts that it had, and get an idea of how high it got. Other things are just text and written descriptions. So the storm of 1945, it washed away a building. It was actually where the current school is sitting. A building was washed away in 1945 and caused a lot of damage throughout the region. So just that kind of context gives us an idea of how high this got in the community. And then another one where floodwaters reached different parts of the community, and these kind of things give us an idea, of course, of how high it was. So as far as a flood history goes, as I've been saying, you can't go to one place and find all the information that you want. And here's an example of sort of how scattered it can be. On this graphic here, each row is one source that I read for all the information they had about flooding and storms for Golovin. And if it has a purple box here, that means that the storm was mentioned in some capacity. Most of the time, it's literally just mentioned that it happens without any more information. Blue is where a storm, I found a mention in that storm somewhere, but it wasn't in that source, even though they covered that time period. And then white is when that source wasn't covering that time period. So basically, you can see pretty much every source is missing quite a bit of information. And some of them are missing almost everything. Some of them have a certain amount. But you can't go to any one of these sources and get everything that there is to know. So that's what we're working on, but not just knowing that the storm occurred, but how high it actually got. So I'm going to show you one example of how we actually estimate the heights that these storms reached, given what we can find. And this is for the storm in November 2013. Here's a nice graphic of how the storm came in. It was actually 4 storms that just drove water up into Norton Sound, and you can see the storm really made a beeline straight for Golovin. And we got a photo from the community. And Steve Ivanoff actually went out there, I think this was like around midnight, and stood right next to where the water was coming up and took a picture. And so he gave us also a description about this. He talked about how the standing water rose about this high, didn't get any higher. Waves were washing onto the road, but waves didn't, like the water itself, the still water height didn't exactly flood over the road and flood into the community. So we take that observation and we use information like his written description in this photograph to get an idea of the elevation that the water actually reached here. So here we took an elevation profile of that roadway and then do some math and see like, okay, so the water got at least this high on the road, but not higher. Part of it was run up, so we'll not worry about that and try to get the still water height here and ultimately get an idea of how high that water was relative to the land and relative to the local tidal data. So when we do that for every community, we get a lot of information. And what we did is we wrote down every part of this process. So we wrote down the resources that mention the storm. We have the information from those resources in an appendix, just the raw data that they said that was relevant to the storm. And then we wrote out our rationale for how we did a measurement for it, whether we could or could not do a measurement for it, and then a concise summary of the results. We did that for every storm that we could. Every storm that we found, tried to estimate it and get those results out there. So you can really get a lot of information from this resource, but we also put it in a nice list if you just want to see it really quickly. So here's a list of storms, all the ones that we could measure that have impacted Golovin. And then there's a list of some storms that were mentioned in sources, and maybe they didn't happen. Maybe it was an error in the source, or we just couldn't actually estimate it. And like I said, we kind of provide all these different levels, so you could go to the original source data, or you can just read about how we actually measured it from the source data. Or if you just need to quickly get this list, you can just look at the list. And so that was a really nice product. And kind of going back to models for a second and just thinking about our current understanding. Currently, if you wanted a list of storms in Golovin, you might go to a model publication like Chapman in 2009. And this is a table from that publication, and it's really good. The heights on this were actually really consistent with a lot of the storms that we saw, but based on actual reports of storms and their impacts, we found that the majority of these didn't seem to impact Golovin, and there might be different reasons for that. Like maybe the model just wasn't quite right, or the trajectory was a little off, or maybe there were ice conditions or something that caused differences. But most of these storms, we didn't find any mention of them in the sources. In 1974, we didn't find enough info, but we do know that it hit Golovin. And in 2004, this was a big storm that came in. We estimated it was 10.6. They got 10.0, and it's not exactly a perfect comparison with what they're modeling and what we got. So that was actually pretty good. I was really happy to see at least one that we could measure was pretty consistent with their findings. However, they didn't see this 1992 storm, which is a really big one. And so ultimately, I'm not exactly sure what to interpret here other than, just looking at these model results alone doesn't tell you the full story of what's happened in Golovin. So I'll talk now about flood impacts. And the big part of this is you can look at this table of storms and how high they got, and that's wonderful. But how does that actually impact the community? How severe were they? And this is a nice photo in Nome from the 1913 storm, where obviously this was very severe. So when you want to communicate flood risk, you want to communicate how an incoming flood is going to actually impact community. And there's different ways to do this. You guys are in weather service, you know this better than me, but there's minor, moderate, and major flood categories. And so we tried to use these for the communities. And we looked at major. This is just a really easy summary, but just extensive inundation of structures and roads, significant evacuations of people. Moderate would be some inundation of structures and roads and maybe some evacuations. And minor is generally no real damage or evacuations, but it does cause issues for the community. And to illustrate that for what that might mean for a rural Alaska community, minor flooding would be like flooding of beach property or near homes, and it could cause damage to boats and important things for subsistence activities, but is generally not a threat to life. Moderate flooding could actually flood low-lying structures and make places impassable, cause quite a bit of damage, but is not the worst. Major flooding, of course, is the worst, where you really get multiple homes flooded, like airport and emergency access cut off, things like power cut off. And so that's, we have a whole list of how these are categorized, but there's just a general idea from a nice visual. But yes, we did get a table. So we got a table of those kind of things. So like in minor flooding, you'd have beach property, the height of the lowest building, and in moderate flooding, the height that water would have to reach for roads in town to get flooded, or for the lowest residences to get flooded. And then the heights of things like when drinking water might be impacted, and when fuel tanks would be hit by water. And even when buildings such as in this one, the high school is mentioned here, that's often a place that's considered like an evacuation center. And so the heights of important infrastructure for community viability are generally outlined here in this table, all relative to feet above mean high water. And then you can bring back in that table of storms, and you start to really get an idea of how impactful these storms might have been. And one challenge here is that when the storm occurred, the town was different. And so for example, the 1945 storm definitely caused major impacts at the time, but the town has taken steps to essentially be higher up. And so if it happened today, it may not have caused such a big impact. But still, quite the storm history. If 4 of those storms happened today, they would cause major impacts. If another 4 happened today, they would have caused moderate, and a lot of minor flooding as well. So just this color scheme really gives life to that table of storms to get an idea of how impactful these events are for the community. And that brings us back to that flood staff graphic I gave you right at the very beginning. So again, small, succinct, and really gives you an idea of how often flooding occurs and how severe it is for the community. So we did all this analysis, put all this stuff together, combined it all into this flood staff, and also made a map. So here's a map of Golovin to show where those flood categories would be. So if water was to be in the minor flooding category, you could expect areas in the yellow to be at risk of flooding. Same with red for moderate and purple for major flooding. So a communication tool that we've put together in this map format, and this is an 8.5 by 11 that folks in the community can print off. Everything's legible, and everything's here in one piece of paper, so they would have easy and quick access to relate all this information that they need. There's also a little conversion to other datums, but everything here is put in feet relative to feet mean higher high water. So there's a conversion to mean lower low and orthometric height as well. We also did this for Hooper Bay. So in this presentation, I of course was just giving an example for Golovin, but here's some of the results from Hooper Bay as well, where you can see, of course, where minor, moderate, and major flooding would impact the community. And also it tells you certain infrastructure that's, from our records, show have never been flooded before. And so finding that cutoff of the top of the purple zone is kind of difficult, but we would do that based on either maybe a modeled 100-year flood or an observed flood to show we wouldn't really expect flooding to get above this based on the history that they've had. So the last part is really just having access to this flood information, especially before a disaster strikes. You know, we can do all this work and create all these resources, but we want them to be put into use as well. So, and here's an example from that 1913 storm again in Nome, where maybe if they knew more about how storms impact that area, they wouldn't have built so many buildings on Earth that can be wiped out from underneath them. So what we're putting together is an online tool, and this is a flood category viewer, we call it for now. But the general idea is you could look at that same printed map, all the information there, just on a website. And here's a look at the tool. It has the map, it has the flood staff, and it also reads in, we have our geographic user interface, we've got our flood staff here, and it reads in the real-time forecast from the Weather Service, the extratropical storm surge. And so you can see what water levels are supposed to be, and then look at the map and get that information. And that's also read in at feet mean higher high water, so everything's in the right vertical datum. Try to reduce confusion. And with this map, it has toggleable layers, so you can actually look at where water might reach when it gets to these certain heights above feet mean higher high water. And here's a little run through of that. And I'll run this again a couple times just because I know streaming a video like this can kind of suck. But you can see, you can just click on and off different heights of water levels and watch where water would flood in the community. And in general, I mean, this is a very simple elevation raise on an elevation model. So it is made to represent still water heights, but we're trying to work on representing well, trying to just be conscious of like run up heights and if that's an issue in places. And luckily here for Golovin, it's not really much of an issue for this kind of graphic. So folks can toggle those on. There's also a lot of other little bells and whistles. We try not to make it too overbearing, but we also have a whole catalog of photos of flooding. And so we can put those on the map with little dots. People can click on them, and you can see a photo of a flood that happened, who took the picture, a little description that we've written about it. And then you could also see, you could look at that storm list and get an idea of where flooding was at that time. So this one was at 10 feet. Put that on and see where the water was. And then it has base map options, so you can turn on different backgrounds and try to see what the community looks like. But of course, base maps can be a mixed bag. But if you click that photo, you'll actually get linked to our DGGS photo database. And there's a link up there if you wanted to check it out. This is live. You can go there now and see all these great photos. But basically, if you click that, you'll get to this photo, and it has all the same information about the photo, the time it was taken, and a little description. But then there's also these links over here, and this will take you to more stuff. So if you had the question, what other storms have flooded Golovin, you can just click the word Golovin, and you'll get all the photos that we have of storms and flooding in Golovin. And you can search by location. It has this nice map over here with base maps as well, where it shows where all the photos are taken. And you can also search by storm. So I want to see, what other places were hit by this 2011 storm, what other photos are out there. And so it's a quick way to see, what impacts were actually noted by communities. And of course, more recent storms, more people have smartphones, so there's a lot more photos. But it's a good, quick way to just see what the storm impacts are like. So to summarize this work, as I said in the beginning, what we wanted to do is just improve the understanding of flood impacts for Alaska's coastal communities. So part of that was getting those historical storm surge heights. And another part was defining flood impact categories. How impactful were these storms for the communities? And then also displaying the results in a way that's easy to access and it's easy to understand. And of course, as you know, working in the Weather Service, it's a lot easier if people understand what you're trying to tell them. So providing tools that everyone can understand and communicate pretty quickly was really important to us. So this will be coming out as a DGGS publication, and that'll have all that information from very simple tables all the way down to like source data. We're still working on the flood category viewer, but that photo database is live. You can go there and click around. It's a lot of fun. And we have a lot of work to do. As you'll know, if you go to the database and just type in flood, you can see there's a lot of places that, that need this information that don't have it. So we are actually applying for funding to get this done for 44 communities. And here's a graphic showing all the places that we're going to be working on this, with different capacity depending on what data sets are available. And we sent in a pre-proposal to the National Fish and Wildlife Foundation. They accepted it, which is very exciting. So we're invited to put in a full proposal. And we do need letters of support for this. So a little pitch here, if you feel like writing a letter of support to get this work to actually happen, you contact us. So again, I'm Richard Buzard. I'm here with the Alaska Division of Geological and Geophysical Surveys. And our program manager, Jackie Overbeck, is here as well. And if you wanted to write us a letter of support, you can contact Jackie and we can get that set up. So thanks, that's my presentation, and I'll take any questions.